This lesson is Finding Limits Graphically. It is section 1-1 of the class. So what exactly is a limit? First thing that comes to mind might be the speed limit, the maximum that you can go, okay, legally. And that is an actual definition, but it's not the definition that we're going to use mathematically. A mathematical limit is defined as follows. A limit is the y value that a function approaches from both the left and right side as the input or x value approaches some value. Now, so we're talking about a function here, a function a function with x and y variables, okay? So the limit is basically the y value that the function approaches from both the left and right side. Now think of it in terms of the graph. If you're looking at the graph, you're going from both the left and the right side as the input or x value approaches some value, okay? So as x approaches some value, if you're looking at the graph, you're going from both the left and the right. What is the y value that that function approaches? Now, what does limit notation look like in terms of mathematics? Okay, so this is basically what it would look like. And it's read as the limit of the function f of x as x approaches a is equal to b. So, limit of the function f of x as x approaches a is equal to b. So let's look at some examples here. And let's start by looking at the first graph here, graph 1, all right? And we've got down here the limit of f of x as x approaches a is equal to. All right, well here's x equals a is right here. Now we're approaching from the left and from the right, okay? Now, if we're approaching from the left, okay, we can see that the limit approaches a certain value here. If we're approaching from the right, it approaches a different value. Okay, from the left, we're approaching this value, but from the right, we're approaching this value. So basically, in this case, the limit does not exist. All right? Because there is no specific value here. So let's look at the second one here. We'll look at graph 2. Okay, the limit of f of x as x approaches a is equal to what? Well, if you're approaching from the left side, it's going that way. If you're approaching from the right side, it's going that way. So the limit is actually infinity in this case, all right? Now let's look at some other graphs here. All right, now let's look at graph 3 here. And if we look at graph 3, so if we're approaching from the left here, you can see that it approaches this value L. And if we're approaching from the right, it also approaches this value L. Now, the function does not exist at f of a. There is no value. There's a hole there. However, the limit does exist there. So therefore, the limit of f of x as x approaches a in this case is L. All right, moving on to graph 4. The limit of f of x as x approaches a. Well, if you're approaching from the left side, it approaches this value. If it approaches from the right side, it also approaches this value of L, but f of a is actually equal to m. But again, that does not matter. We're talking about the limit here. So it's going to get closer and closer and closer, and what does it get closer and closer to? L. Okay, so the limit in this case is also L. And then lastly, graph 5, the limit of f of x as x approaches a, we're approaching from the left, we're approaching from the right. In both cases, it approaches this value L. The function of f of a is equal to L, but the limit is also equal to L. Now, occasionally we have what is referred to as a one-sided limit. A one-sided limit is the y value a function approaches as you approach a given x value from either the left or the right side. Okay? So you could have a one-sided limit approaching just from the left side, or you could have a one-sided limit just approaching from the right side. All right, let's look at an example here. We've got a function f of x, and we have two limits here. We have the limit of f of x as x approaches 2 plus. Now, the plus means we're coming from the right-hand side. In the other case, we have the limit of f of x as x approaches 2 minus. That means we're coming from the left side. So when coming from the right side, we're going down like this, and we approach this value here, or minus 4. When we're approaching from the minus side, we're going in this direction, and we approach this value here, or plus 1. All right, let's look at another example. We've got a rather interesting shape here, obviously a piecewise function, and we're looking at the limit of f of x as x approaches 0, the limit of f of x as x approaches 1 from the left side, the limit of f of x as x approaches 1 from the right side, and the limit of f of x as x approaches 3. Now notice, it doesn't have any plus or minus, so that means it's from either side. So the first one, x approaches 0 from both sides, okay? So we're coming from the left and the right. The answer is obviously 2. Now notice, there's a hole there. The function doesn't exist at x equals 0, but the limit does. All right, now let's look at the limit of f of x as x approaches 1 from the left side. So that means we're coming down like this. And as we're approaching 1 from the left side, we're obviously going to approach this value, which is minus 1. Now, how about if we're approaching 1 from the right side? If we're approaching 1 from the right side, we're going to approach this value here, or 0. Now, notice, at x equals 1, what is the value of the function? The value of the function is up here, but the limits are down here, okay? Now, let's look at one last thing here, and that's as x approaches 3. Now, there's no plus or minus, so that means we're approaching from the left and the right. Well, the left side approaches this value, the right side approaches this value, so therefore in this case the limit does not exist, or there is no limit. All right, to conclude, let's look at when a limit does not exist. When does a limit not exist? And that is if the left and right side limits are different. So we're not talking a one-sided limit here. We're talking that you're coming from the left and you're coming from the right. If those limits are different, the limit does not exist. Unbounded behavior, in other words, infinity, in other words, a vertical asymptote, okay? We could have coming from the left, it could be going up to positive infinity, going from the right, it could be going down to negative infinity. And then oscillating behavior at the x value. So those are the three cases where the limit does not exist. The most common one that you're going to run into is this one right here, the first one, where the left and right side limits are different.